This is going to be a very quick lesson. There's only a couple of examples. And what we're looking at is finding the probability from a normal distribution. So in the last section, we looked at the area under the standard normal curve. And we talked about that. That was associated with the z-score and everything. So now we're going to look at what is the probability under that curve, or the probability and the normal distribution. When a random variable x is normally distributed, you can find the probability that x will lie in an interval by calculating the area under the curve. So we're doing basically the same thing we did in the previous section. We're looking at the area under the normal curve. To find the area under a normal curve, remember what we do is we convert to z-scores, and then we use the standard normal distribution to find the area. So this is just showing you an example that on this one, if we had a mean of 500, and it looks like we have a standard deviation of, looks like about 100 here, showing you the standard deviation is about 100. So we have a mean of 500, a standard deviation of 100. And then what we do is we convert that to the z-score. So when we convert it to the z-score, we end up with the mean being 0 and a standard deviation of being 1. And when you do that, you'll notice that the area under the curve here, the normal curve, the area under that normal curve at a mean of 500 is the same as the area under the standard normal curve. So these match up. So when we convert to that z-score, it allows us to see the same areas or that same probability. So on our example, finding probabilities for normal distributions, a national study found that college students with jobs worked an average of 22 hours per week. The standard deviation is 9. So that's telling us that the mean is 22 and the standard deviation is 9. A college student with a job is selected at random, finding the probability that the student works for less than 4 hours per week. So our x value, assume that the lengths of time are normally distributed and are represented by the variable of x. So our x value is the value they're looking for, particularly for this student, which was 4 hours per week. So what we're going to do is we're going to find the z-score that's associated with x equals 4. So remember, our z-score formula is a really easy one. It's the value of interest minus the mean divided by the standard deviation. So this would be 4 minus 22 divided by 9. 4 minus 22 is negative 18, divided by 9 is negative 2. So we have a z-score of negative 2, and we would look at the standard normal table, and I think I forgot to include that here. No, I didn't. I've got it. Okay, so the standard normal table, and we're looking for z equals negative 2. So I'm going to have to scroll down here, and I included on here. And all I did was, this is the one I found that's one of your tools, and or you can look at the e-text at the very back of the book. So I'm looking for a z-score of negative 2. So I'm going to go down to z equals negative 2.0 right here, and I want it to be 2.00. So I'm going to go all the way across to the 0, column, and when I do that, I get 0.0228. So the probability that the student works for less than 4 hours would be the probability that the z-score is less than negative 2. And what that's referring to, if you're thinking in terms of that standard normal curve, then the probability that we're less than a number is always going to be the area under that curve. That's going to be to the left of it. So the probability that z is less than negative 2 is going to be that number that we found in our table. So 0.0228. So the probability that the student works for less than 4 hours per week is 0.0228. So the interpretation of this would be 2.28%. If you move the decimal over twice, that would be 2.28% of college students with obviously college students with jobs worked for less than 4 hours per week. And once again, if we refer back to that being whether that's usual or unusual, anything less than 0.05 is unusual. So this would be an unusual event. That if the college student had a job, it would be unusual for them to work less than 4 hours per week. Okay, on example 2, we want to find a probability that's between two numbers and then a probability that's more than a number. So we have survey indicates that for each trip to a supermarket, a shopper spends an average of 43 minutes. So that's our mean. It's the average is the mean. So the average is 43. Standard deviation of 12 minutes. And the lengths of time spent in the store are normally distributed. It's always important that we can only use the standard normal tables if it says they're normally distributed. They're normally distributed and are represented by the variable x. Shopper enters the store. We're going to find the probability the shopper will be in the store for each interval time listed below, and then we'll answer the part B after we do that. So between 22 and 52 minutes, in order to use the standard normal table, we have to convert our values to z-scores. So we have to convert for x equals 22 and 52, we have to convert those to z-scores. So if x is 22, that's going to give us our first z-score. And then again, I'll write the formula down. It's just x minus the mean divided by the standard deviation. So if we do 22 minus the mean was 43 divided by 12, that comes out to negative 1.75. And then we'll do the same thing for x equals 52. So we'll call this the second z-score. So 52 minus 43 divided by 12 would be 0.75. And you'll notice if your x value is less than the mean, you're always going to get a negative z-score. If your x value is more than the mean, you'll always get a positive z-score. And then what we want to do is go to our table. And in our table, we're going to be looking at negative 1.75 and 0.75. And we want the area between those would be the probability that it's between those. So I'm going to scroll down here to my table again. And I'm looking for negative 1.75. So I go down to negative 1.7 and then across to 5. And that's 0.0401. So we'll have that number. And then the other one was a z-score of 0.75. So I'm going to go down to 0. And we want it to be positive 0.75. So going all the way down, there's 2 pages of these. One page has the negatives and one has positives. So I'm going to all the way down to positive 0.7 and then across to the 0.5, and that's 0.7734. So all we do if we want to look between two numbers is we subtract those two numbers. So I'm going to take the 0.7734 and subtract the 0.0401. So for our answer, we would have the probability that z is between 22 and 52 would be my 2 areas that I found from the table. And then this is going to be, so the probability that is less than 0.75 minus the probability that it is less than negative 1.75. And you wouldn't necessarily have to write this on your paper. I'm just so you can see what I'm subtracting. So we found this one in the table was, and all you have to do is remember you subtract the smaller one from the larger one because these will always have to come out to be positive. So 0.7734 minus 0.0401, and then that comes out to 0.7333. And then our interpretation, of course, of that would be that we have the 73.33% chance that your shoppers would be in the store between 22 and 52 minutes. Okay, so that was number 1. Okay, and then now I'm going to do number 2, and then I will go back and answer part B. We want to know what's the probability that they'll be in the store more than 37 minutes. So this time our x equals 37. So we're going to get a z-score of the value minus the mean over the standard deviation. So 37 minus 43 divided by 12. And when we do that, we get negative 0.5. So once again, I'm going to go to my table. And remember, this one is, just so that we'll remember, when we do this one, we're looking for the probability that z is more than. So I'm going to have z greater than, a z-score greater than negative 0.5. So keep that in mind as we finish the question out. So I'm going to negative 0.5. So I've got my negatives. So I'm going to negative 0.5, and it's negative 0.5 exactly. So you're going to scroll over all the way to negative 0.50. So that's where you can see both of them all the way across, negative 0.50, and that's the 0.3085. So 0.3085, but if we're going greater than, that means we're going to the right, and that number in the table always gives us the amount to the left. So anytime we're going to the right of the number, we always do 1 minus the number from the table. So I'm going to do 1 minus 0.3085, which would come out to 0.6915. So that would mean there's a 69.15% chance that they would be in the store for more than 37 minutes. Okay, part B says, when 200 shoppers enter the store, how many shoppers would you expect to be in the store for each of the intervals listed? Okay, so this is my part B question, and this is really easy to do. You take your probability, which is your percentage or your probability, and you multiply it by the number of shoppers. So for the first one, which was between 22 and 52 minutes, it's going to be your 200 shoppers multiplied by that probability, 0.7333. And when you multiply that, that comes out to 146.66, which would be about 147 shoppers, because obviously you're not going to have a part of a shopper. So you would round to the whole numbers. So that would say that you would expect of the 200, oops, I put 2,000 there, that was 200. Of the 200, you would expect 147. You would expect those to be in the store between 22 and 52 minutes. Okay, and then for the other one, it was they would be in there for more than 37 minutes. So more than 37. So you would say if 200 shoppers enter the store, the probability they're in there for more than 37 minutes is 0.6915. So if you multiplied that, you would get 138.3. So that would be approximately 138 shoppers. So of the 200, about 138 would be in the store for more than 37 minutes. Okay, and then this last one, there's not really anything to work here. I'm just pointing out how to do these on the calculator again. And we have the mean is 97. If you read through the problem, the mean is 97. It says they're normally distributed. Again, very important. Standard deviation is 25. And you randomly select an adult who is at least 20 years old. What's the probability the person's level is less than 100? So if you want to go less than 100, what you're going to do is, again, you run through the steps. You put in second, and then the vars button, and then it's number 2 is normal CDF. And when you push that, it will ask for a lower, and it will ask for an upper, and then it will automatically have mean is 0 and standard deviation is 1. So for your lower, it just needs to be a very small number. Like I said, this textbook uses negative 10,000 every time. You could do negative 1,000 and you'd still be okay. So negative 10,000, your upper is, it says 100. We're looking for the probability that's less than 100. So 100 is our upper. And we put all that in and it comes out to this number right here. So when you put that in, again, you have to use your arrow to go down or hit enter several times to get there. And we end up with the, whoops, I'm sorry, I didn't, the mean, we didn't transfer those. So the mean would be 97. So you're actually going to change the mean and the standard deviation here. So this is what the whole point of this is to show you, and I wasn't paying attention. The whole point of this was to show you that you don't have to transfer them to z-scores to use the calculator tool. We have to transfer them to these scores to use the standard normal table, but on the calculator, you can actually put in, instead of being the mean of transferring these to z-scores so that this is 0 and 1, you can actually put in the 97 and the 25. And then when you do that, it calculates it for you. So with the calculator, unless it tells you to transfer it to a z-score, you can actually use the normal CDF without changing them to z-scores like we did on the previous examples. If you're using the table, you would have to change this 100. For the 100, you would have to change the 97 and the 25, and the 100, you would have to use those numbers and change it to your z-scores before you could use the table.